Welcome back to our Python lectures, and today we will look at Python dictionary data structure on what advantages, when to use them, when are they better than lists, when are they maybe worse. Dictionaries are the second most important data structure available in Python as far as complex data structures goes, and extremely useful. Again, you see the regular dictionary in like a human dictionary. There is analogy there actually, right? You look up some word, and you have you have some values, you have some information about this word. Well, the Python dictionary has some similarities with this approach. The main thing is we have some keyword, and we can look up this information extremely quickly. Very in a constant time, no matter how large our dictionary is, maybe it has 100 million items, even maybe billion items, we can still look up this information very quickly. Or let's look at another picture what Google developers offers us. So we have a collection of keys, and they map to some values, right? So keys have to be unique, and values could be pretty much anything in Python. So that's what the Python dictionary is, the big idea, right? So we have a key A, or maybe my name or something like that, and we have immediate access to the values. Okay, so that's the big idea. Again, they have some similarities with lists. In fact, there are some languages, programming language, where you have array. In Python, this would be a list, and then you have something called associative array, which would be a dictionary in Python. Again, we'll see that some syntax similarities. So let's go to our actual day 8 materials, and we are opening up our dict.py file, and we'll take a look again. So the defining characteristic, they are key value pairs, right? They are not ordered as far as we know in ways how we would order, say, a list, right? Again, some other language called associative array, maybe map or hash map, right? And the key part is that we have so-called, in a data science or computer science terms, so-called O1 lookup. What this means in real life means no matter how large our dictionary is, as long as if you know the key, we can get the value very quickly, basically almost instantly, right? So you can compare it if you have a huge list of items, right? You need to find a specific item. If you don't know the index, you'll spend a lot of time looping and looking for something. So that's why you need dictionary, right? If you need some keys associated with some values. Again, on the dictionaries in Python are mutable. What does it mean? We can change the values, we can change, of course, the keys. And so dynamic, of course, mutable meaning we change the values. Dynamic, we can add or remove the keys, right? And by extension, of course, we remove the values associated with that key, right? So they are iterable. That means basically we can loop through them, right? Technically, order was not preserved, but from 3.6, Python 3.6 and on, actually the order is actually preserved of insertion. But okay, and they can be nested. So together with the list, you can have a very hierarchical high, many levels of hierarchy by nesting your lists and dictionaries on and on. Again, this will be very useful when we're dealing with JSON data types, right? Dealing with JSON, this will be quite useful. Okay, so that all sounds good. It's all theoretical, but what happens in real life, right? So we'll start as usual. We'll start with an empty declaration. And in Python, there are two ways of making an empty dictionary. The easiest, the laziest, of course, is do just blank curly braces. So compare in a list, compare with list, so compare with, right? So again, so if you see curly braces, remember Python does not really use that many curly braces as compared to many other languages. We do use some curly braces in Python, for example, for formatted text, right? F strings use curly braces inside. So this is a little bit different, right? This is not different, it's quite a bit different. So again, we don't have infinite symbols, right? So curly braces do serve some multiple purposes. But in many other languages, which come from C languages, they use curly braces everywhere. So in a way, Python is much easier to deal with curly braces, right? If you see curly braces, probably something to do with dictionary, right? So other approach is just to use a dictionary keyword, right, which creates a new dictionary as well, right? Of course, more common is this for blanks, but this will be more useful when we actually want to put something in, right? This is actually, you have, again, you can treat it as a function, you put some parameters inside, and actually you can create dictionary from, say, from two lists, for example, right? So again, but by extension, that means you should not call your variable, right? Don't call your dictionary, right? Maybe call it my dictionary, you know, or actually say, even better name would be, best name would be what you are going to store, right? Best dictionary name would, no, that's not the best one. That's too generic. Would actually explain what it stores, right? What it stores exactly. Thank you, my AI assistant. On it stores. So something like, for example, I don't know, my books. For example, let's see, some phone book, user info, etc., etc. Okay, right. So if you're going to print some empty dictionaries, well, you'll see that it's not really too exciting, but we'll see some, you know, curly braces, right? You print curly braces, so that means that there's an empty dictionary here, right? Again, let's do an empty dictionary, the first one, right? So you can double check. Again, you can check the length, and you can check that it is what its type is, right? So this is going to be, of course, class dictionary, and there's no items inside, no key value pairs inside. So let's make some actually, so we can actually pre-populate. We can create a dictionary with some values, right? So that's what we're going to do right now. So notice notice the syntax here, right? So curly braces on keys. This is a key. So I'm going to enter two keys. Okay, there's a key 1 on colon on value. So in this case, there's no indentation after colon, right? When we are creating dictionary key value pairs, right, we use colon. So key value. So again, this is like this, right? Key value, right? So and comma, and you have next pairing. So question might be, we'll look at it, what can be a key and what can be value. And I can tell you already that values can be pretty much anything, but there are some restrictions on what keys can be. Well, in other words, they have to be immutable, meaning they cannot be changeable. So strings are perfect for this, because strings you cannot change themselves, right? So strings make great keys. We'll look also what do with integers. Yes, they will be usable, but probably not to be overused. So strings are the classical key, right? And values, again, in this case we have keys are strings and values are integers, but that is not Python being very liberal. We don't have a really strict restriction on this. Okay, so let's print our micro dictionary, and you see curly braces, key value. Again, does need to be double quotes or single quotes, doesn't matter, of course, because strings, that's just in strings in Python, that doesn't matter what you write, right? I'm using single quotes here. So let's add a new entry, and basically it's as simple as using this syntax, and this already is familiar. So notice I'm using tel, right? That's my dictionary name, and I'm using square brackets, right? You might think, okay, what happened to curly braces? No, we're using square brackets, just like in a list, but except we have the key name, right? Key, in this case it's a string, Maya, and she has a phone number 2653, right? So I had a new key value pair, right? And by the way, if this was already existing key value pair, then Maya would get a new phone number, right? In this case she doesn't have it, so we'll have a new addition to our dictionary, right? So Valdis Liga Maya. Again, notice how I'm using a Latvian long E, right? That's, of course, just any string will do. That's allowed, of course, no problem whatsoever. All right, so the main use of this is to do lookups. Again, so dictionaries are amazing for this. Again, of course, so if I need to look up my phone number, right, all I need to enter is my name, and this is basically like a Well, you can think of it as a special in-memory database, right? Some people actually use this Python as a database, right? You can store actually this, so 26440, right? And no matter how many entries, well, practically limited by your memory, right? You can have again tens of millions of entries, and this lookup will be very, very fast, right? So less than a second for certainly, right? Instead, if you had a big list of phone numbers, right? You take some time to actually go through them, right? Unless you know the index, right? Here, we can think of it as an index, but it's actually string key, right? So, okay. What else? We can look up, of course, use a variable. We can use a variable as a key, right? So again, very typical to use k or key or k, you know, a letter key will be also fine as a variable, right? So my key, right? And we get the value. Of course, this is just a simple, same thing as doing this, right? I enter a key and I use it here, right? Variable as a key, right? And in this case, really, it could be anything. Of course, it could be, you know, key could be any variable. I mean, key could be named anything, right? This is just, of course, for educational purposes, right? So of course we get Maya's phone number, right? And I just mentioned, right? So mentioned, like, I thought Maya didn't exist, right? I put her, so she got a new key. There was a new key value pair addition to our dictionary. But however, if I am actually exist, right? Well, I can put 1118, right, as my value, and well, so the requirement is that keys have to be unique. So if there already key val this exists already, it will be overwritten. Again, we'll see that keys are also, of course, by definition, case sensitive, right? So the capital V will be a different key. And then there's a question now. I had students ask me, what do you do if you have many phone numbers? Well, one simpler way of dealing it, you store them in a list, for example. Actually, it could be some other structures, for example, tuples, but let's do dictionary. So this is a load. This is a little bit more complex. This gets more complex, but notice, so Valdis, key Valdis corresponds, right, to a list containing 3 phone numbers, right? Well, 3 numbers, of course, right? But Liga and Maya only has a simple integer, right? So the data types are not matching, right? That's completely fine in Python, right? It gets so flexible, right? Of course, it's best if you have same data type, right? That is much better, easier to deal with. But it could happen you need to store something like this. So I can store my phone. I can see my phone numbers, right? On 2626, right? On I can get my last 911, right? I'll get the last phone number. I can do it using this syntax, because why? Because this key lookup, right, corresponds to a list, right? This list here, right? So I can get the last value 911, or for example using just regular list indexing, remember, or positive or negative indexing, your last item or third item, right? Same thing, we'll get 911, right? It should be happening, right? Let's see. Yeah, and we get 911, 911. Okay, so that's all fine. Let's move on to how do we store the data, right? So of course the values, if we need to use them separately, there is no restriction. You can use them as a variable. Of course, you can store let's say we have a new variable, my phone, right? Maya's phone, and we can store the value associated with this key. I have my phone dictionary, I have my key, right, which is Maya, of course you can see here, right, and stored. Of course, this has, once it's out, this has no relation to the dictionary. I just have a data out on, in this case it's primitive value 2653. It's just a number, right? So as I mentioned, the keys are case sensitive. So what this means is that if I start playing around to Valdis Z, right, you know, I don't know, Valdis Zatlers or president, right, or former ex-president, right? So 1001, 1002, right, these will be completely different key value pairs, right? Of course, not related to my phone number, right? Right? And I still have, by notice, Right, notice first of all, notice how in the modern Python, since I'm using Python 3.10 here, the order is preserved, right? Valdis was first, Lig was second, Maya, then Valdis Z and Valdis Z, right? Two different Valdises, right? The order was preserved. But now, okay, so I want to go back to my regular phone number or just a simple number, right? I can do this, right? I can go back, and of course, now it will be, I'll have it back here, right? So notice something else here, right? So 1001, right? So keys are unique. That's a requirement. Keys have to be unique. However, values, right? Valdis has 1001, and this also has Valdis Z, also has 1001. And that's also completely fine. So values can match, right? That's why I'm showing you this, right? So 1001, right? So it could be anything, right? Red, orange, whatever number, whatever it is, right? They can, so values, so multiple keys can point to the same value, basically, right? All right. So, yeah, I mentioned I can add more Latvian, Unicode, Lithuanian, any language, right? Keys and strings, that's completely fine. Again, so Liga, I can do this. Peteris, right? Peter, right? And notice again, no problem whatsoever. And the values can be duplicated, right? Because again, well, so happens, you know, so the keys are, like I said, unique, right? The lookup, the unique way of looking up. And the values, of course, could be whatever you're looking up. You know, it could happen. You are looking up the same thing, basically, right? So, and again, you can even, strings can be, string keys can be of any length, including white space, right? So something like this, right? This Valdis, second, Peter, the son of Peter, right? So, of course, again, kind of silly example, but yeah, that's completely valid key. That is completely valid key, and right, you'll see now that this is here, right? See, my key is here, right? Key and its associated value 1888. All right. Well, we have all the silly keys, right? Let's take a look. How do we look up keys directly? All right, we can do that. So it is actually, so tell keys is going to give us something very interesting. Well, it's going to look like a list of keys, but it's not quite the same thing. It's actually a dictionary key special, something very similar, because you notice here are square brackets, right? So this is actually a list of keys, but it's not quite the same thing. So if you really need to convert your keys to actual list, right, you can do so like here, right? You can do so here, and this will give you a list of keys, right? And well, I didn't print it, but it is actually going to be a real basic list. Again, no relation to the, now it's gone completely to the dictionary keys anymore. It's just a list, right? So similarly, right, we can do the same thing using it values. Again, values, again, we can say, okay, I want to get all the values, right? I don't care about the keys, right? And I have a value list, right? So notice dictionary values. It's a specific type, so it might be easier to use a list. So give an argument this dictionary type, right? And it will create a list. Remember how we used range? We can use, so we can call a list on it, and we'll get a real list. So this, so we have two lists. We have a list where we have this list here, right? That's one list, and we have another list here, right? So again, they used to be in a dictionary, they are key value pairs, but as lists, they are completely independent, right? However, right, well, I'll do some little construction. So we sort of deconstructed our dictionary into two lists, okay? Well, I'll do some tricks. I'll add Ruta, right? And I'll add a value for her, right? But again, they are not, of course, for now, they are not together, right? I could, of course, done this tell Ruta 1018 directly, right? Like I did before, but in this case, I have two lists, right? Two value pairs, right? And why am I doing this? Because I want to show you something interesting, right? So I can create a new dictionary from any two lists, or actually any two iterables, even ranges and so on, right? Very, very convenient, right? I can create a new dictionary, right? So notice here how it's done. So dictionary, and there's a new keyword or a function zip. So what it does, it goes to well, any iterables, right? In this case, list, and sort of puts them together, zips them together like a zipper, basically, right? Something like this, right? You have a very cool thing, actually, right? It gives you basically pairs of items, right? In this case, actually, we could have more, and you can use the syntax to create a new dictionary, right? And let's take a look. Right, so notice ruta is here, right? So you see ruta is here. So let me do maybe, let's do it before, right? I'll add key list append, right? Append. Well, not ruta, but that's something else. Maybe something, I don't know, edit, right? Edita, I did it, right? And well, however, I will not add a value for edit, right? So what will happen, right? So what will happen with this zip, right? So notice edit is here, right? However, since using zip will make will create pairs, yeah, as long the shortest list. So that's key to keep in mind, right? So you'll be making the pairs, but of course edit doesn't have, right? And of course I got something more, right? So key list append, maybe, I don't know, maybe, well, Valdzali has it, right? So I don't know, Minces or somebody, I don't know, some cat name or something, Kitty, right? On something like that, right? And Kitty doesn't have phone number, right? So notice again, so in this case, so Kitty and edit, that they don't get the phone because I didn't add them to the list, right? So if you are zipping two lists together and try to make a dictionary, of course it'll work as long as there is a way of creating this pairing, right? So basically like this, right? You go make a pairing, key value, until we run out of one side runs out of values using this zip. And again, zip is really convenient, actually, right? So when you have to deal with these data transformations, again, Python makes working with going back and forth in real life situations is quite common, right? You have list of the items, you need to somehow put them together, right? And using something like this type of structure might be quite convenient. So again, notice again, so my new dictionary has ruta, my old was not changed. Okay, right. So let's now this is maybe slightly advanced, right? So let's go a little take a step back. Let's see if we have time still. Yeah, we're doing good. Right, let's look at existence check. So if I do well, this will work, right? Well, this will work, right? Still works, right? My phone number will work, right? What happens with the joker? Well, there's no joker in my dictionary. I hope not, right? And yeah, it's a key error joker. I get a key error. Okay, so how do I deal with it? Well, remember, I can check. I'm going to comment this out since I don't want to deal with the error right now. And I'm going to check these three. I can do existence checks, right? I can check for a membership check, right? So membership check, membership test, right? So using in. So true, false, false. One thing is that the key lookups are extremely quick, just like the value by key, right? So I could use this knowledge. I could use an if statement, right? I could create an if statement and check whether there is something here I could use to look up before I go and check this value. I could check, right? I could do something like this. Let's see, key is Valdis, right? And I could do a little if statement, right? If key is in my value, right? I want to get the value out. So Valdis exists and I get 1001, right? Okay, here's your value. Here is value. So let's do f string. Maybe we can do f key, right? Key, right? On value value, something like this, right? I could do something like this, right? Using my f strings, right? Something like this, and as you'll see, key, well, this value 1001, right? Very nice. However, if I go and change it to Nevaldis, right? And of course it'll be sorry, no such key, right? Because I'm gonna override this. I'm not even gonna comment this out, right? I could, but I'm just gonna overwrite this Valdis with Nevaldis, and of course Nevaldis doesn't exist. Sorry, no such key, Nevaldis. So okay, that's all good and well. We could use this approach, but Python is already thinking of making you write less. You can use, if you are not sure, if you need the if you don't want to handle errors yourself, which actually we have not really dealt with yet, you might want to use something, a pre-built function. There is something called a getter or get, right? So you can use it to get values. So telephone get, right, a method, value for key if it exists, right? So this will not throw an error. So notice something interesting, right? So, right, on. So I got 1001. However, if there is no such key, I get back none. So it's not going to be an error. So again, if you are sure of keys, you use this syntax, right? You use this syntax, existent. If you don't know about the keys, if you are sure, so this will be slightly optimized, this kind of if statement. This will check if there's no key, give you none. That's already nice enough. That already saves you some time. But it's even better. You can use it to provide the default value. So, okay, you say, okay, if you get, there's no such key, then you give this message, right? You get the actual value, default value. Instead of default value being none, which is like an empty nothingness, right? You want to actually provide some value for those cases when you don't have a matching key. And yes, sorry, no such key found. So, if I provide my existing key, well, what do I get? Will I get my phone number or will I get this? Well, since it exists, I will get the matching key for this, matching value for this key. As you can see, 1001, right? So, let's see what else, right? So, I should mention, I'm gonna usually have the question, how do I check for the values, right? Well, you can check. However, I should warn you. So if I want to check if key existence, so key existence is very quick, right? This, if you have a big dictionary, will be slow. This in a big dictionary, right? So this is a slow check. Checking for 1001 in telephone values, right, will be slow. It's true, right? So checking through values, because he has to create this and he has to go through the list, right? So this is very, very, very slow. Yeah. Again, here is some weird keys. I'm not going to show you. Can do pretty much anything, right? You can do an empty key. Yeah, it's actually a valid key. But yes, let's see. You can actually even have an inner dictionary, like I mentioned, right? You can do this. You can do this here, right? This something like this, inner dictionary, right? And now you have a key called inner dictionary, and it has a matching inner value actually, right? So very, very crazy, right? It's possible. Again, we saw this part here, right? Or get. So I think we get to the looping. Maybe we don't have a pop and push methods, but let's go for looping, right? So looping, probably something you'll be doing. You want to go through all the keys in your dictionary. Use something like this, right? So just remember that one thing you should remember is, when you are looping through a dictionary, do not change the size. Don't add or remove elements. Well, we don't know how to delete, right? For example, how to delete. Maybe we'll get to later. Might be something. So we know how to add. We can delete. So we can do delete if we know the key. If we know the key, we can delete the key value corresponding from the dictionary. Okay, so how do we do it? No, I don't want to delete myself. I want to delete this inner dictionary, right? Again, I think it's a little bit makes things complicated, so I'll do inner dictionary, right? So deletes deletes the, well, I can delete, let me delete that this val, this, let me delete this crazy thing, right? I'll delete this, okay, since I'm lazy. So I'll delete this, right? Alright. And also I'll delete this inner dictionary. Right, I can delete these keys, alright, and then we'll be, Peter is also maybe later, I'll delete him as well, but the inner dictionary, yeah, delete again. Yeah, okay, and now we'll see printel, we'll see it's deletion. Right, so looping, this is not looping, deletion. Yeah, so, and then we get to looping, and then I think we are going to be in very good shape, right? We're almost finished, right? Oh yeah, very good. Right, so, and then we'll be able to have to look at, so, I deleted inner dictionary, and then deleted also this, well, this Peter, son of Peter, right? So, again, I could of course delete some more, but okay, so let's loop. So let's loop through, right? So the key part is to remember not to modify the dictionary you are looping through, right? That can be, I mean, you can modify the values, but you can't change the add or remove keys. So don't delete or add new keys. Yeah. So, right. So we see key Liga value 291, key Maya, key Valdis Z, key Peter, right? So we got that. All right. So we saw how we can do for key in the dictionary. This is the most, I mean, the easiest. So we basically, remember, there's no need for get. We could use get, right? But of course here, right? But this is going to be slower, right? Sorry, Control Z, right? Control Z. Here, oops, again, I'm getting tired, of course. So tell get key would work, but it's not really needed. This is going to be slower, right? This is the slower part right here, right? You'll see that it is actually. We'll see, right? Exactly same results. Get is slower for get, which is slower since we are guaranteed key, right? Get is, so use this one, right, in looping. But also there's something very interesting. If you need both and you don't want to use this lookup, I personally prefer using this approach, which is, I think, is often, this is fine too, of course, right? But items is a special collection, dictionary items. You see these pairs, right? You have a sort of like list of actually tuples, but it's of little pairs, right? And you can go through these, right? So this is an idiom. You want to go through all key value pairs in a dictionary, something like this, right? So this is something very interesting. So we can use. I provide 3 ways of printing out the results. Of course, again, we can add. We can change the numbers, right? So, for example, we could change values, but not keys, right? Not keys, right? So that's important to remember, not to change keys, right? Right. So you see here, right? So you see different ways of typing, right? This is something Python 3.8 syntax. You have key, value, right? And it will provide you already pre-made. Otherwise, of course, you can do this key value, and key value. So this syntax is good for debugging. Otherwise, it's not really useful. It's just good for debugging. All right. So we saw key value. Again, you can print, of course, something else, right? You can collect something, right? You can remove. So there might be a question: how do you remove items if you need to filter something, right? Well, the answer is to make a new dictionary, and we will look at that in the class, right? So how do you change it, right? So to do, I'll add to do here. So do mutate dictionary while looping in a safe way. All right, safe way. So that's what we're gonna do in the class. For now, I hope you got a reasonable look at value, how this key value mapping, how it works. And again, the main thing why we do use it is because we have a very quick, guaranteed quick lookup. It's really actually fascinating how it's done, right? How these hashes are made actually, right? Of course, underneath there is actually something like, well, like a list or an array, right? So we basically get indexes for this data structure very quickly, numeric indexes. But otherwise, so dictionaries are very, very useful. Again, when you have these, when you need to look up something by a key. All right, so thank you, and we'll see you in the class. Thank you.